So in this video, we're going to look at a way to make a shader like this, sort of like an orange peel, but it's got sort of more applications than this. We can alter this to make it look more just like a glossy kind of wet surface. If I change some of these settings here and take a look, we can see that that fine specular that was broken up is sort of just warped into this more liquidy specular on top, as if it's coated in something. So you can take this simple setup and adapt it to different scenarios, and I'll show you how to build this. I'll just go back to the normal setup I have here, and let me just walk you through what my scene looks like. So you can see, obviously I have a big HDR image in the background from HDRI Haven. This is the hospital scene. I have a single area light. Its spread is set to 0.2, and that is to have more light fall off. So it treats it a little bit more like a spotlight, because the intensity of light spreads from the middle out, and so your exposure becomes more intensified in this smaller area on the area light. Everything is turned on in these lights in terms of the light types they're casting. So even the background light, the skydome light, has got SSS on, which I sometimes turn off if it's too taxing on the render. A background plane here, which is in reference mode right now. My little object, a little stand, and there's my render camera. Okay, so let's take a look at the shader here. So we're starting with just an AI standard surface, and I'll rebuild this from scratch in a sec, so you can just see what's going on. So we just start with a basic AI standard surface, and then we have a bump node here that is carrying an AI noise into the bump of this shader. So if I just turn off my coat value for a second, so we can just see the bumpiness. So you can see it's just got a slight bump on the surface, and that is coming from this bump node and this AI noise. You'll also notice they have this AI user data float node attached here, and this is just taking a value into scale X, Y, and Z of the noise. That's how you change the sort of granularity or size of the noise. And instead of just changing the value 3 times, I can just type a value in here and get a different amount. So you can see the bump scale changes. So the other thing that's going on here that is what allows us to have that broken up specular. Let me turn the coat back on. So this is in the coat attribute of the shader. So what we have here is similarly another AI noise, and this could be anything. This could be an AI cell noise or any other type of noise that you have here. I've got this setup as well, where I've got this AI user data float connected to the scale, so I can change the value here easily. And then I have the out color of the noise going into the input of an AI range node. And the AI range node just allows me to change the contrast of the noise easily. So if I just isolate selected, you can see what the AI range noise is doing. Sorry, AI range is doing to the noise. So this is the noise as it is. But then when it goes through the AI range, I just use that to increase the contrast a little bit. This is going into a bump node, and then this is going into the coat normal. Okay. Let's turn off isolate select. So let's try to rebuild this from scratch so you can see what's going on. I'll keep this one here in case I forget what I'm doing, and I'll just turn this off. So we just have to start with an AI standard surface, of course, and I'll just call this demo orange. And I'll just drag this onto my ball, and let's render. So we just start with our standard material, as we would expect. So we can make some adjustments here. I can change it to an orange color. Oh, there we go. Something like that, or maybe something like that is a little bit better. So I'm going to use a combination of specular and coat. So right now we have specular turned on. And we control the specularity with the roughness. So the rougher it is, the more diffuse the specular is. And then the IOR, the higher it is, the more kind of reflective and metallic like it is. So I'm going to keep this at the standard of around 1.5. And I'll adjust the roughness here. And I can adjust the color here too if I want it to have sort of a bloomy sort of effect. If I maybe want to make this a little yellower or something like that. For now, I'll just keep it at white. In this one, I gave it sort of a pinky tinge. And then the roughness was at about 0.25 and everything else stayed the same. So let's just try and do the same thing here. And 0.25. Okay, so there's no transmission. I am using subsurface, but we'll add that after. And I am using a little bit of sheen too. So, but let's first add our bump. Okay, so we'll just create an AI noise. And I'll create an AI user data float. And I'll create an AI bump 2D. So there's a built-in Maya bump node and an AI node. The controls are essentially the same on the AI bump node, except it starts at a more reasonable small value. So to connect this up, we just take the out color red of the bump of the noise into the bump map value here. And the reason we use red is because bump map can only accept a single channel value. It can't accept RGB because it's just black to white. And then we will take the entire out value and go into the normal camera. Okay, so we're not really seeing anything because the AI noise is so big right now. And to make it a finer noise, we increase the scale. So if I went to 10, 10, and 10, then we can start to see the noise appearing a little more. And if I go to 20, tab 20, tab 20, I can see smaller and smaller. So you can see that I need to type the XYZ scale in here. So what I'm going to do instead is use this AI user data value, data float, to connect to all three aspects of scale. I learned this from an Arvid Schneider video, and this is really handy. So I'm just going to connect the out value here to all three of these. And now we're at 0 because there's no value in here. But if I put this to 30 now, then it just feeds that into scale X, Y, and Z. I'm just going to save my scene. Okay, so now we can alter the bump by changing the bump height here. So if I go to 1, which is the standard for the built-in Maya bump, and you can see how terrible it looks. So we'll just keep it at that low value, 0.1, but we could go to 0.05 and, depending on how bumpy you want it to look. And then, of course, we can change any values here in the noise. If we want to increase the number of octaves to make a more complex noise, we can do that. We can increase the distortion, whatever. So this is all procedural. And so you can see already that kind of loose specular is giving this that kind of waxy look of the orange surface. But what we're going to add here is another noise. And I suppose I could actually just select all these three things and duplicate them and then reconnect them. So the same thing with this noise. I'm just going to take the out value of this user data float, connect it here. And this one, I'll just put this to, I'm going to change the bump value to something lower and then have a higher value for this. So let's just name this so we know what's going on. So this is coat noise. This is coat noise scale. Let's leave the name of this one as is. So I'll take the out color red into the bump map here, and then the out value. And what we want to connect the out value of this one to is this coat normal down here. So let's just first take a look at what coat is doing for us. If I turn this up, it's like an extra layer of specular, right? So it sits on top of the bump and everything below. So it's good for making something look like it's got a clear coat on it. And we have the same controls that we have for specular. We can increase the roughness to spread it out. We can increase the IOR to make it more intense, so much so that it becomes metallic if we go too high with this. I'm just going to go back to the 1.5 for now. And then we can change the anisotropy and the rotation of that if you wanted to have some directionality to this. But I'll just leave that alone. And what normal does is it kind of breaks up the coat. So it's just like a bump map. It's changing the direction of the normals locally, so it breaks up the coat. And when you want to make a surface look different in terms of what the specularity means, of how waxy it is, how dry it is, how wet it might feel, it's that kind of breaking up the coat or the specular that really helps. And this coat normal does this very well. But you need to use an AI bump to connect to that, or something that has a built-in normal control. There is another, and there's another thing I learned from Arvid Schneider, but there's a flakes, AI flakes, that can also be hooked up directly into anything with normal in the name, because that can be used to control that sort of thing. But we're just going to use an AI bump with a noise piped into it. So I'll just middle mouse drag this bump onto the word normal here, and it will ask me to connect this. And so I'll connect the out value to the coat normal here. And here we can see it's already working. So if I just reduce this bump value to 0, I'll just turn it off. Now we just get nothing there. Let me turn off the specular so we can compare. So I'll turn specular to 0. So this is just our coat now. But with this going into, this bump going into our coat normal, we can break up that specular. So 0.2 is quite high. It's 0.05, 0.02. Right, and we're getting something more along the lines of what we want. If we isolate select, we can see what the coat noise is here, and it's not going to show us what this bump height is doing. And so if I go back to the value I started with, 0.01, we can get something like this. So that's one way to control that. We can also go in and change the coat noise here. We can change the size of it, so that's at 30. If we go back down to half that, so we can see we've got a bigger noise that's breaking this up for us. Right. So something like that. I'll just change this back to 30. And we can also put a range node in here if we want to control this a little bit more. So if we make an AI range, and we take the out color from the noise into the input of the range, and take the out color R, put it into the bump height, so now it's just traveling through there. But we can change the output max, and let's just isolate select so we can see what we're doing here. So if we start to increase this, you can see we're just making it more contrasty. If we turn this off, and we're really breaking up the specular. So we can just work with this however we want. This is almost back to normal, but it just gives it a little bit more control. You can turn up the contrast here too. That does something similar. So we can play around with these different settings to get the kind of look we want. And that is taking out too much of the coat for me. So I'm just going to reduce this down until we get something like this. My bump is a little bit too high for me. So we can go into the coat and, into the shader and adjust the coat as well. So if we increase the IOR, we can make that brighter and more kind of glossy feeling. And we can also adjust the roughness to make it fall off. With no roughness, it's very slick kind of feeling. And so it's this balance between the IOR and the roughness that will help you make it look wetter or waxier or shinier. So when I first was trying this, I was putting noise into the weight, into the color to try and break this up, but it doesn't work nearly as well as putting a bump with a noise into the coat normal. So finally, we can tweak this to have a couple of other things, subsurface and sheen. So sheen, I can just use a little bit of. So what sheen does is it uses, if you have specular light being cast at this thing, then you can have this sort of glancing angle specularity. I'm going to make this a little bit yellow, and then the roughness here will determine how far towards the camera view it will come. So I'm going to reduce this so it's a little tighter to the edge, and then just turn down the overall weight. So it's just going to be just a little bit of extra color around the edge. And then this is looking a little bit plasticky still, so we could save the file. We could add some subsurface scattering. Now my samples are very low for this, so it'll be a little bit noisy. But if I turn this all the way up, so we're just getting subsurface scattering going all the way through, and we can change this color to be something more appropriate. So a similar orange, maybe a little bit warmer. And now it looks like a candy, like a lollipop or something. So I can reduce the scale until it's a little more reasonable. And we're not going to use a full subsurface scatter weight. It makes it look a little too waxy. This would look more like the inside of the orange, where light can travel through a little bit more. So this will depend on the size of your scene and so on. And then the radius here, this is how sharp the shadows will be, really. So if some part is in shadow, how much light can travel into that shadow from other areas. So again, another trick I learned from Arvid Schneider is to, now I'm not sure how well this will work here because I've got light coming from all directions, but if I put an object over top of this that's casting a shadow, we can get a feeling for what the radius is going to be doing. So we can see the shadow now being cast on this. And if I increase the radius, oh, sorry, that's the scale. If I decrease the radius, we should start to see a sharper shadow, because less light that can actually strike the surface can go far enough to get into this shadow. So a lower radius will have sharper edged core and cast shadows on the object. But another thing you can do with radius is click on the color, and if we change this to RGB 0 to 1, we can have different aspects of the color travel a different distance through. So I can go to 0.8 for red, And now red can travel further into this shadow area. And then we want this to add up to 1 in total. So now what's happening here is that red can travel further than green or blue. But for something like this, maybe since I'm trying to make a fruit, maybe I want to hint that there's a little more green traveling through. So 0.2 red, 0.6 green, and then 0.2 blue. So something like that. And then once you have those relative values put in there, you can just dial down this if it's too broad. And then overall, I would just turn down the subsurface scattering. That, to me, that's a little bit dark inside. So I look at what I was rendering before, it was more like this. I'm just going to get rid of this ball. Oh, that's a little better. So that's what I had before, and that's what I have now. So I'm going to tighten up that this AI range a little bit. Break up my specular coat tad. And then I think my coat is maybe just a little too bright. So I can go into the coat and reduce the IOR to 1.5. Maybe that's a little low. Could reduce my roughness. So it's a combination of those two things to get the look that we want. Just going to spread out my sheen a little bit, and then maybe turn up my subsurface scattering a bit. And then I'd still have my specular. I can turn that on, and that just kind of gives a rougher specular underneath that does react to the bump that's on the surface. So here I just have fairly rough, fairly standard IOR, and just this sort of pink kind of color, just to add a little bit to that. And so now, if I wanted to make this look a little more kind of glossy rather than like the surface of an orange, I could go in and change my coat noise value to something lower. And now it looks sort of more like it's got a wet surface or something, a shellacked kind of surface on top, which kind of looks interesting too. So there you go. I hope this is useful to you. It's a pretty simple setup with some quality of life enhancements to make editing a little bit easier. So go out and try and make it and see if it works for you. Thanks.